it's time for our next talk, and I guess we should have tested our stuff better so we wouldn't have any technical issues. Chris, welcome to Comference. It's good to have you on, and I'm going to give you the word about testing in the real world.
Sure. Thanks, Scoop, for the introduction. And given how weird 2020 has been, this is the only conference talk I will be doing in 2020, which is a big departure for those who know me. Today I want to talk a bit about the topic of testing. So this talk is entitled Testing in the Real World. So my name is Chris Hartjes, and for the Dutch folks in the audience, yes, I do have a Dutch last name. I believe it's actually properly pronounced Hartjes. It means little hearts. My father's family background is from Germany in Gelsenkirchen, which is near the Dutch border. And I have one of my great-great-grandfathers is Dutch. So a Canadian person with a Dutch last name of German background just shows how weird the world really is. So what I do is I talk about testing and whatever other nonsense is rattling around in my head. I've been getting paid to write computer programs since 1998. I believe the first work I did was when the switch from PHP 3 to PHP 4 happened. And then around 2005, at the job I was working, we had a very terrible launch, and I started doing research into ways on how could we make these things suck less, and stumbled upon extreme programming, and as part of that stumbled upon the further section on unit testing. And once I saw that, I was like, you mean I could write more code to verify that my existing code is working as expected? And that was a revelatory moment for me. So I've been shouting at people on social media about testing their PHP code ever since. So this time around, I want people to understand when we talk about testing, I've spent a very long time focusing on the tools. And then in recent years, I've switched to talking about people using tools, because testing is actually more about people than tools. In the real world, testing is about convincing people who are otherwise not convinced that you should be spending time and effort to come up with some sort of repeatable process for testing your application code. And it doesn't matter what language it is. These days, there are testing frameworks for pretty much every programming language out there. So instead, we have to realize a few things when we talk about testing in the real world. One of the unalterable truths is that testing adds extra time to the work that you are doing, because testing is code for the most part. So it's extra code that you need to write and debug and verify the test itself is executing correctly. And then you have to take the time to run your tests and verify your code is behaving as expected. There's overhead in terms of deciding what the test scenarios are going to look like. So adding testing to your workflow, it will take extra time, right? And I talk a little bit more about that later in this talk. So that's in the real world, this is an absolute truth. Testing will make you it'll go longer to do things, but the idea is that we're going to spend less time fixing problems at the other end of the whole software development lifecycle. And there's the story we talk about cost, right? Testing is really about shifting the cost of fixing bugs to what I would call cheaper situations. So let me illustrate a story about this. The absolute cheapest time to have a bug fixed is when the developer has their editor open and they're doing something with the code. They're adding a new feature, they're refactoring something, or they're fixing a bug. If a developer finds a problem while they're doing their task, they can usually, if it's code related, fix it right then and there. So you could say the cost to fix a bug that you find is X, where X is some fraction of the cost of the developer, right? Now, if you're using tools that help you find bugs, then hopefully you'll find bugs and other problems at that stage of the cycle. But if you're not using those tools, or the tools aren't being used to their full potential, you will then move to the next step, which is hopefully someone else other than you is taking a look at your code and looking for problems. If you find a problem there, then you have to circle back to the developer, and the developer has to again address the issue and fix it. So that maybe now costs twice as much to fix, twice X, where X is how much that developer's time costs. So if a bug is not caught there, then maybe it moves to some sort of QA or more like functional testing environment where someone is actually trying out more features than just the little tiny bit of code that you were working on. If you find a mistake there, now maybe the cost to fix it now becomes 3 or 4 times the cost of the developer's time, because now they have to go back, evaluate the problem, write some code, fix the problem, hopefully. Then it's got to go to a code review. Code reviewer has to thumbs up it or thumbs down. Then it goes back to your QA or staging environment. And then somebody else has to spend some time verifying that the problem they found no longer exists. And then if a bug makes it all the way into production and is discovered, well, all bets are off as to how much it might cost to fix that problem. It could be trivial. It could cost a fraction of the developer's time. It could be 5 times the cost of the developer's time. It could be 10 times the cost of the developer's time. There are some categories of bugs that literally destroy businesses, right? Dropping, you could drop a database as part of a migration and you don't have any backups. So there's all sorts of things that could go wrong when a bug makes it into production. Not to mention the tendency of people to panic in a stress situation where 4 or 5 people are trying to solve a problem found in production. So a lot of these, not all of them, but a lot of these problems can be addressed in a much more calmer fashion and for cheaper if developers are given tools to allow them to find as many bugs as possible before we get into a production situation. And finally, as like a more high-level thing, I want people to understand when we are talking about testing things, we are verifying behaviors, not code. We are writing code to make our applications behave in a specific way. We should be coming up with testing scenarios that are about proving the behavior of the code. And testing the code is how we verify the behaviors. But again, I encourage you to think about this as in terms of behaviors, not code. I'm not testing my code. I'm testing the behavior of the code that I've written. It sounds like a little like pedantic or picky, but when you get into the habit of thinking about tests in terms of scenarios that verify behavior, you find yourself writing fewer tests, and the tests are much more related to how the application as a whole works. So as I describe things that happen in the real world when it comes to testing, I'm going to be telling us a little story that features 3 characters. So the first character is the experienced tester. Perhaps this story is a little bit autobiographical, but the experienced tester says things like, we start with a test as if everything is working, and then we write code until the test passes. So that is the path of the experienced tester. Then we have the enthusiastic beginner. We have a developer who has some understanding of the programming language and has discovered testing and says things like, I've bought all these books and I'm ready to write tests so my code never has any bugs again. And then we have the third person, which is the frustrated programmer, who looks at this and says things like, this blog post about testing does not reflect the reality of what I'm working on. So we have 3 characters and 3 different personalities when we talk about testing in the real world, and they all have their own strengths and weaknesses that they bring to the process of when you're trying to figure out how to test something. They have and to be perfectly clear, every one of these characters has their own flaws and misconceptions about testing, right? So the experienced tester is trying to help you along the path to testing things by hoping to simplify things, by encouraging you to always think about the task at a much lower level than you currently are. We're not focusing on the application as a whole. We're worried about this bit of behavior by this small bit of code, and then we're going to write a test to verify it. And the hope is that by simplifying things and breaking it down into smaller and smaller units, you will not be overwhelmed by the task of testing. The enthusiastic beginner is hoping to learn a new approach to programming. They've been burned by bugs, or they've had other people of similar experience to them, start learning how to test their code, and they've had lots of success. So the enthusiastic beginner is diving into the books and blog posts and social media and videos and courses and the whole ecosystem surrounding testing in hopes of learning a new approach, right? And then we have the frustrated programmer, which is probably what the vast majority of people are in this case. They want advice that can immediately be applied to their problem. They're not concerned about the low level. They're not concerned about the high level. They're trying to make something work. They're frustrated that it's not going the way that they want, and they want a solution that can be immediately applied. But what they all have in common is that they're all looking for better outcomes. The whole reason why they've decided to evaluate testing tools and test-centric approaches is because they want better outcomes. So now I'm going to talk about a few scenes and scenarios, right? Because ultimately the real world does not care, right? There's a slightly vulgar joke that says, screw your feelings, or facts don't care about your feelings. The real world does not care about your opinion on testing, right? What the real world, and by the real world, I usually would refer to as the people who are using the applications that come out of the work that you're doing, they care that the application works as expected. They probably don't care that what technology you've created it with. They probably don't care what programming language you're using. They probably don't care whether you have automated tests or not. They care, the real world cares, does this thing that they're using do what they want it to do? And no matter what happens, if it doesn't do what they want, they will blame you. They won't blame their web browser. They won't blame their phone. They will blame you, because they will say, this thing you made does not work the way that I expect it to. So when you start thinking about tests in that terms, you understand your goal is to make the end users happy, and anything that happy and saying this thing is doing what I want it to do. Anything outside of that is really about managing expectations or trying to make sure that people who are really mad at you, don't dedicate the rest of their lives to making your own life miserable because they didn't like what you were doing. So to look at the perspective of the three different people and what they've identified as being correct and what they've identified as not, what they are misunderstood about, I want to run through a few scenarios here. So our first scene here is that we have no code. Our project is just getting started. We've done some design work, and we've decided the first step is we're going to write some code for some entity that represents a user of our application, right? So the experience tester would start off by saying, great, let's pick some behavior of that user entity, and let's sit down and figure out what a test would look like, okay? What the experience tester is trying to do is, again, simplify things, right? By saying, by sort of like guiding you towards the idea that we don't have to worry about the application as a whole. Let's really concentrate on this one bit of behavior. And if we build all our tests this way, if we put some thought into it, that we'll end up with stuff that works the way that we expect, right? The flaw of the tester, of the experience tester, is the experience tester can sometimes be blind to the skill level of the developer who's writing the test. You may still be in the prototyping stage and trying to figure out what all your APIs and interfaces look like. And the experience tester knows you can do that sort of spike and stabilize cycle of explore something, see if you like how it looks, explore it some more, then commit to the approach, then let's start writing some tests. But the blindness of the experience tester in this scenario is sometimes failing to recognize the skill level of the developers who they're working with. They may not have the whole application in their head. They may be kind of overwhelmed at the idea of, I'm going to start with one little tiny bit of a larger application. Then the enthusiastic beginner looks at this and says, okay, I've created a skeleton for my test for the user entity. Maybe they're lucky enough to be using some sort of code generation tool. And now they say, now what? So the role of the enthusiastic beginner here is to point out to the experienced tester that they're blocked because they need some help deciding how to take that first step. The enthusiastic beginner understands there is some structure and approach they need to take, but they don't know where to start, right? So the enthusiastic beginner is somewhat blinded not realizing there is a very large step you need to go from understanding how to code and then understanding how to write a test for the code you are about to write. And then we have the frustrated programmer who looks at their own experience and says, these tests are going to slow me down. I know a code needs to be written for this. I'll do the tests later. So the frustrated programmer understands that tests are additional work. And a lot of programmers are lazy and don't want to do extra work. And that's fine. I'm certainly not a big fan of doing extra work. But the frustrated programmer's blind spot in this scenario is that they are saying they'll go back later and write the tests, and instead they are not using the testing process, especially test-driven development, as a way to design your APIs and your interfaces and what your code is supposed to look like. Going back after the fact to write tests will often result in a test suite that is brittle and missing a lot of edge cases that you're going to have to worry about. And the tests may be flaky and pass sometimes and fail in other situations because because the code wasn't written with testability in mind, right? So again, let me go back to this other slide just a sec. Again, like understanding that in this scenario, the experienced tester has good intentions to simplify a thing, but they misunderstand about skill levels. The enthusiastic beginner has good intentions because they know they need some structure, but they are blind to the idea of making this leap from coding to coding with testing in mind. And the frustrated programmer knows that there's going to be a lot of code that needs to be written, but they are blind to the fact that they need to slow down. And by slowing down, there will be fewer mistakes and refactors that they need to do later. So, illustration about how every one of these characters has a strength and weakness. So let's think about scene number 2, right? Which is probably the most common scenario, where we have a working application but no tests, or maybe there's tests and nobody uses them, right? Which is probably you're in a worse off case, right? So in this situation, the experienced tester says, no problem, let's talk about what parts of the application need to work every time we push to production and think about how to test those. So this is the strength of the experienced tester, understanding we're testing behavior, but we already have some constraints in terms of what we can do. So instead, let's shift the conversation up a level from deciding what code to test to deciding and looking at what parts of the application are critical and what cannot break every time we push. And if you find yourself in a situation where you're like, everything has to work every single time we push, well, you probably have some bigger problems, because if everything is a high priority, then nothing is a priority. So in this case, the experienced tester is trying to push the conversation up one level to where it needs to be, but at the same time, they are ignoring and not aware of that there may be some business constraints in place as well, right? So then the enthusiastic beginner, and sorry, this slide got a little messed up. The enthusiastic beginner looks at a working application and says, oh, these code samples, they don't look anything at all like the samples I've seen for writing codes. I wonder how I can modify this so I can inject a mock dependency for a test. So the enthusiastic beginner still lacks the skill on how to turn test dependency, how to take the dependencies for a test and create them for your testing scenario. But the role of the enthusiastic beginner in this scenario is to actually what they're doing is they're pointing out all the existing problems with the code and pointing out what is testable and not testable. I encourage many, many people who are working with programmers of all sorts of different levels, pay attention to what the beginning or less experienced programmers are telling you about the state of your code, because you may have internalized a lot of the problems and no longer see them as a problem. You see them as a fact or a condition of the code base. Listen to the beginner when they say, I want to test this thing, but I have no idea how to modify the code to make it testable. That is a sign that along the way, something went wrong with some architectural decisions. Sometimes you can fix them, sometimes you can't. And then the final part of this story is the frustrated programmer who looks at the situation and says, the app works. I need to keep building those requested features. All that time spent writing tests isn't worth it right now. So what the frustrated programmer has correctly identified is that we have a working application that is solving a problem. And it is very important to keep the application in that state. But what they are ignoring is that they talk about how they need to keep moving forward with new features, and that all this time spent writing tests isn't worth it. But what they're not realizing and what they don't know as one of their flaws is that they are likely spending more time fixing bugs and addressing technical debt than they are writing new features. So if they had the ability to have more tests for this application at the beginning, or pause new feature development to go back and get some tests for the important parts of the application, then they will be spending far less time fixing bugs, and they will actually get to move the project and the business forward by creating new features so people can keep giving you money so you can continue to get paid, because this is what we're trying to do, right? So again, so finally, what we have is a very common scenario as well, where the scene is that we have some tests, but the team has stopped working on them for whatever reason. Deadline pressures, people switching positions, people leaving. We have a test suite that's in a partial state, but it's not being used anymore, okay? So what does the experienced tester looks at this scenario, and they say, no problem. Let's start, but we're gonna write a test case to verify this bug that was reported. So the tester now understands that we can shift back to a lower level in terms of figuring out tests and start using these tools to make sure that bugs that are reported get fixed. And then the next logical step is, great, then any new code that gets written, we are going to require a test, right? And so they realize, the experienced tester looks at this and realize the return on investment and return on effort to go back and write tests for code that doesn't already have tests, the return can be really, really poor, especially if you're in a position where the stability of the application and the application, and the ability of the application to continue to fulfill the goals of the user, and in many cases, make money so that everyone can continue to get paid. That is what is important. But again, what the experienced tester, the little flaw that they have is, again, perhaps underestimating how much work it will get to change the minds of the people who've been doing the work. Because if the test suite hasn't been worked on, chances are the developers working on the application have decided it's okay to ignore the tests and have stopped thinking about how to test every single thing that they write, okay? So the tester has some good ideas, but perhaps they are underestimating how much work it will take to get there. The beginner goes, again, a similar problem to where they're going to write tests for a working application that has nothing. Like, I know they need to write tests, but now I'm stuck on how to best test this code I'm being asked to fix. They may lack the experience to go look at an existing test suite and then figure out, okay, they wrote this type of test for this part of the application. I can use that as a template to do similar things. So the enthusiastic beginner wants to do the work, but they're blinded on how best to get there. Experienced tester can help them by pairing up with them to show them, all right, let's work together on a problem, and I will show you how I would approach writing a new test or extending an existing test to meet those goals. So we're at a point now where we need collaboration, whereas before, the tester could do things on their own, the beginner could do some things on their own, the frustrated programmer could do some things on their own, but now we're at a point where we require collaboration. And as we know, collaboration is about people and processes, not about tools. And then the frustrated programmer looks at this and says, I'm already late on this part of the project. I have no time for tests. I think this fix should do it. I'm going to, merge this thing directly to the main branch, and we're going to push it up into production. So the frustrated programmer recognizes we have time constraints, that we're probably late on the project, but they are blinded to the fact that, again, it was this constant desire for forward momentum at all costs, and an unwillingness to slow down, write some tests, verify behavior so that we don't go back and fix things. I'm very confident when I explain to people the reason the tests are worth writing is because we end up with fewer bugs in production. Many years ago, about 12 years ago now, I think, it's 2020, my COVID-19 brain never knows what day it is. It's like March the 375th, I think, of 2020. There was a study done by Microsoft and IBM where they took a programming problem and assigned multiple teams to it and told some of them to use test-driven development to build the application and some just to use whatever they wanted. So when they finished the study, what they found was that the teams that used test-driven development, it took 20 to 40% longer to finish the test, which makes sense for what I was talking about earlier, where we have extra code that needs to be written, extra time taken designing things, extra time putting tooling and other processes in place. But what they found was that compared to the teams that didn't use test-driven development, you had 40 to 90% fewer bugs show up in the production application. So this showed, and this was one of the first times that a study had actually been done to show real world impact of tests. So if, like me, you wanted to convince people that, you have to convince your manager or your team lead to give you permission to spend time getting tools installed and reworking processes to make things more test-centric, you could say things like, for one extra day a week, we'll end up with 90% fewer bugs in production. Now we know that's a nice idealized version of the truth, but the facts, and we want to stick with in the real world where facts are the thing that matter. Having tests for your application, having some sort of repeatable process for verifying behavior will result in fewer bugs making it into production. So we have the final scene where we can talk about here, right? Where we have the perfect scenario that I like to see. We have a good test suite and we have test-centric development processes, meaning all the developers are on board with writing tests for everything and no code ends up in production without reviews and checks. And hopefully we're having the fewest number of bugs possible ending up in production. So the experienced tester now can look at this and say, great, now let's talk about the steps to go from manual deployments to fully automated releases. The experienced tester looks at this situation and again, shifts the focus from the low level of the code to higher level issues. And then the experienced tester will start introducing complementary tools that go well with test-centric strategies. We'll start talking about deployment tools and build servers and introducing the concept of continuous integration and continuous deployment. And then we can start talking about static analysis tools and mutation testing and linters and code formatters, all these things that provide a great additional value, but you need to have that base of a really good test suite with lots of coverage, and a test suite that gives the team lots of confidence that it continues to get used. So again, the flaw of the experienced tester is that now you are introducing for some people a bunch of new tools and some uncertainty on the best way to apply those tools and processes to an existing structure that appears to be meeting the goals of the business, right? And now the enthusiastic beginner goes, wow, this is all great, but now I need to extend some functionality. And I'm worried that I can't figure out the code. And I apologize for the slide being a little bit bigger than expected. Figure out the code and the test at the same time. So the enthusiastic beginner is actually at a disadvantage in this environment because everyone else around them hopefully understands how we write code, how we write tests for our existing code to test for behaviors, and how all these pieces work together. The enthusiastic beginner will now be overwhelmed. So again, they will need some help and support, and this is the people part again, from other team members Perhaps there's an experienced tester on board, or, you know, they have a mentor within the organization who can pair with them for a while to show them, let's take some code and extend it. Let's write some tests and extend it to cover functionality that we need to worry about. So, you know, the tester has the enthusiastic beginner has the safety blanket of the tests telling them you've broken something, but they're sort of overwhelmed as to how do I take what appears to be a well-oiled machine and add something to it without breaking. And the frustrated programmer will look at this structure and again feel like the process is actually slowing them down. These are things I've heard before. I'd be done with this feature, except my PR hasn't been reviewed yet, or I would be done with this feature if I didn't have to go and write the tests. And because the frustrated programmer has not fully bought into the idea of test-centric practices, their tests probably aren't as good as they could be. So they'll be flaky, meaning that sometimes they pass, sometimes they won't. They could be brittle in that if you can't change the code without, you can't change any code without seriously refactoring the test. So they start ignoring, even though the tests are there and getting run, they start finding ways to ignore the test. So again, the frustrated programmer understands that there are more processes and more time spent to get the end result of what you've written ending up in production, but they are ignoring the associated costs of that. They're ignoring the mistakes that happen because computers are good at doing what we tell them to over and over again, but humans not so much. So mistakes happen and delays happen, and the problems for the wrong reasons feed back into the frustrated programmer's idea that that the tests aren't worth it. So now we fade to black from our wonderful 1-hour training lesson on testing, and we're back to me. So I want to kind of go over the points that I had here to reinforce it, and what the roles are for all these people, right? In the scenario where we are starting off fresh, the experienced tester is the person that will get leaned on the most, but they will need to teach the enthusiastic beginner and the frustrated programmer the structure and the necessary discipline to go with a test-centric approach. How we will write a test where the test assumes everything works perfectly, and then we will go back and write code until the test passes, right? So in that scenario, it is the experienced tester that we need to lean on for cues as to what to do. In the second scenario, where we have an working application with no tests, you would think it's the frustrated programmer that we would need to lean on the most because they would understand the system. No, it's actually the enthusiastic beginner that we will lean on, because the role of the enthusiastic beginner will to show all and highlight all the problems with the code and all the parts of the application that were not written with testing in mind. And then it will be the job of the experienced tester to identify how those problems get fixed, and again, guide us to a more test-centric approach. Then in the scenario where we have an existing application with a test suite that's not being run, this is a scenario where, again, the experienced tester is the person that will be leaned on the most, where they will need to use people skills, not technical skills, to get the team back to relying on the test suite as their source of determining whether things are working correctly or not. And so that will require them working with both the enthusiastic beginner to get the enthusiastic beginner to adopt a new approach, and getting the frustrated programmer to go back to using the tests that they had. And then when we have an application where we have a working application and a good test suite and some good test-centric practices, even though the frustrated programmer is complaining about things, they are the person we actually need to listen to the most, because they will be showing us which of our new policies are causing friction, and maybe we should go back and look at some of them and figure out these processes that we have in place, are they meeting the objectives that we want them to? Are they leading to code with much fewer bugs and problems making it into production? Maybe some of the processes can be tweaked. maybe some processes that were manual before, we can try moving them towards a more automated process and see if we get better outcomes going from that. So in that scenario, that's a scenario where the experienced tester should listen to the frustrated programmer, and the enthusiastic beginner should take cues from the experienced tester. Don't necessarily get dragged in by the frustration of the frustrated programmer, but instead look to the experienced tester who wants to get things going back into the proper direction. So again, testing in the real world is about people, is about collaboration. The experienced tester cannot fix all the problems of the scenarios alone. The enthusiastic beginner does not have the acquired skills or knowledge to deal with these problems. And the frustrated programmer is putting up some self-imposed roadblocks towards getting to the ultimate outcome. So all three of them can work together to make sure we end up in the state of a working application, solving problems for people with a great series of repeatable tests to verify the behavior, and then processes in place to make sure as new behaviors are added and existing behaviors are modified or fixed, that we continue to make sure everything works as expected in our production environment. And testing in the real world is about understanding your strengths and weaknesses. There can be a lot of ego involved in programming, a lot of feelings of imposter syndrome because you feel like you don't have the necessary skills. There's also, you can also have a very high level of overconfidence where you're confident your previous experience will allow you to just obliterate any obstacles in front of you. But you need to understand the things you're good at and the things you're not good at, and then help people who are not good at the things you are good at get better, and then seek out help to get better at the things that you know you're not good at. And this applies not just to testing, but applies to so many other parts of being not only a modern web application developer, but to be perfectly blunt, to be a functioning human being in society. And finally, I think testing in the real world is about behavior first and code second. Once you start centering yourself around, I am verifying the behavior of this code and behavior of the application, you will find yourself writing much different tests, and the tests themselves will have more impact. So I've reached the end of what I wanted to talk about. So thank you, and good luck. And Scoop, I'm open because we've got like about, 20 minutes or so. I would love to field some questions, and I still have my screen up, and I don't want to expose people to inception by minimizing my slides. Did I miss everybody?
Of course, I had my microphone turned off.
All right, so yeah, I've minimized things, and I'm actually in the Discord channel, and yeah, I would love to take some questions and talk about things.
Yes, so let's have a look if there are any questions at this point. I don't see any questions yet. I see someone writing though, typing. No, we are still here.
All right, awesome.
So that's good.
Yeah.
So I'm guessing there are no questions.
So I guess everyone who listens to my talk is an expert tester now. That's awesome.
Yes, well, that's how it works with your stuff, right?
Yeah, to sort of expand on what I talked about, for me, the big shift was understanding that mastering the tools only would take you so far, that you then had to move on to the even more difficult task of convincing other people to adopt the same things. And testing, as I talked about how the experienced tester just goes up and down through levels of showing people, here's some strategies to fix things at the code level, then here's some strategies to fix things at the process level. And the enthusiastic beginner and the frustrated programmer, due to their circumstances, are stuck at a specific level. In the case of the beginner, they haven't acquired the knowledge and skills to move to another level, whereas the frustrated programmer, because of their frustration, is stuck at a specific level. Okay, so I do see a question. So someone was asking, how would you start with getting big legacy projects and proper coverage, and would you block pull requests if they don't have tests in an open source project? So I'll start with the first one. I think what you need to do is what I talked a bit about already, is that at some point you put your foot down, metaphorically speaking, and say, going forward, everything that we do needs to be accompanied by instructions on how we verify that this new feature works as expected, or that this bug is fixed. It doesn't necessarily have to be an automated test. It could start off with, the first step might actually be, here's a checklist here's 10 steps to go through with the application itself. And if you get to the 10th step and see the following output, the feature is working as expected. So that could give us a template to then move from a fully manual process to a semi-automated process where perhaps we're writing, we write some PHP unit tests that are executed manually, to having your tests as part of like a GitHub action, and your test suite gets run every time there's a pull request. So the second thing is, would you block PRs if they don't have tests in an open source project? Okay, for my projects, yes. I would say if you have a feature, or if you're building something and I have an existing test suite, I need to see an automated test that verifies this thing is working as corrected. Of course, your mileage may vary. Some projects don't want to do that. But me being a grumpy person, I don't care about your feelings. I will just reject your PR and say, come back to me when you have a test. So the next question I see is a question: how would you advise migrating 5,000 integration tests to faster tests? Okay, so this is a question about approaches to testing. So you generally have two camps when it comes to writing what I would call unit style tests, where we are like using PHP unit to create a test. You have the one camp that says we will avoid using test doubles, meaning mocks and stubs and things like that. We will avoid those at all costs and use real dependencies. Then you have the other side that says I'm a control freak about my test scenarios, and I want to be able to control the state of every single dependency that my test uses. So the pros and cons of the approach. The ones that are using real things are essentially integration tests, right? They will be slower because you will be interacting with real web services, real databases, and then you have extra added overhead of making sure whatever real dependencies your tests are relying on need to be maintained. So congratulations, you are now a database administrator or a DevOps person, making sure that your testing environment is always completely in sync with production. So that's why the tests are slow. Tests that talk to the file system, that talk to third-party APIs, that talk to real databases will be slower. Then on the other side, if you've made the commitment to using mocks and test doubling tools, you now have all this additional overhead of creating all these dependencies. And then on top of that, more overhead to make sure that the dependencies you've created match the existing code, because they can get out of sync. You can actually end up with tests where you are creating a double of a dependency, but that dependency doesn't actually behave that way anymore. Your tests will pass, but the code does not actually work that way. So, but the advantage to a test suite that is using almost all doubles for things is they will be lightning fast. So if you have a large test suite that is all integration style tests, it will take very long to run. And then people will hesitate to run that test suite because they may have to sit there for a half hour or an hour or even longer to get feedback on whether or not their change worked as expected. With the other test suite, you can run the entire test suite in seconds. I've seen test suites that rely heavily on mocks and doubles that run thousands of tests in 10 to 15 seconds. So it allows for a much tighter feedback loop. So long story short, if you're worried about how long your integration tests are taking, look at them, figure out, can we move these to using more doubles to speed up the time? Or you may just have to accept that the test suite takes forever, and put some processes in place to try to mitigate the impact on that. So the next question is from Michelangelo, who asked me, do I create user profiles for my testing, and how are you using those profiles? No, I've never really messed much with user profiles. I've always more looked at it in terms of the behavior of the code I'm trying to test. User profiles are like a very old concept from testing, and I'm sorry to say that one of the people that pioneered user profiles has said that they felt they were a mistake and have distracted people from the real goal of writing tests. So no, I don't use user profiles. Sorry. So I was at, how does one test without mocks when there is no test APIs available for external APIs? Yes, so this is a common thing. Often remote third-party services are rate limited, or you may not be able to, you may be able to only access it, X number of times a day. So there's a couple of ways that we can deal with this. In some cases, third-party API providers will give you a sandbox with unlimited usage, but with a limited amount of features. So maybe write your tests with that in mind, and have some configuration in the background via feature flags or something else to say, when I'm in test mode, use this URL for the API, and when not in test mode, use the production thing. The other thing you can do, if again you don't have a sandbox to it, what you could do is start creating some code that is a wrapper around the API access, and then modify your code to use the wrapper. Even if it's just like a simple pass-through thing where you're mimicking all the same calls and interfaces and all that stuff. But in your test, then you can create your own version of the wrapper, and then your code can use this wrapper, and it doesn't care that it's not really talking to the real version of the API. It just knows how to use this thing that you've given to it. So that is always my suggestion with APIs. Wrap the code that actually speaks to the API in some other thing, and then create doubles of that wrapper and use that as your dependency. Yeah, wrapper with a W, Scoop, not like a real wrapper. Yes. So I guess any other questions? Because again, like the fact of the matter is, I could talk forever and ever about this stuff, so I try to keep it short and insightful, because me rambling forever is not good. So I see a bunch of people typing, so let's wait to see if a few more questions come up. While we're on this topic as well, I am happy to answer any questions people have about testing, about programming, about all other things. The best way to get in touch with me is probably Twitter, where I'm a Grumpy Programmer without the U. I also answer emails sent to me. You can find me at C Hartjes, so CHARTJES @grumpy-learning.com. I am happy I do read every email that comes into me that makes it through the spam filters, and I will answer things that I can. Yeah, Micah, it's very good to see you as well. I hope that one day, once the world is no longer on fire, I can make my way back to Europe to see all my good friends I've made over the years. But I'm stuck at my home out in the middle of the Canadian countryside, surrounded by millions of acres of corn and soybeans and dairy cattle. So, and the border to the U.S. from Canada is locked up nice and tight. So no chance of me going into the U.S. anytime soon. I think we've seen the flames coming over the border wall and decided not to go in there anymore.
It sounds like a wise thing. Someone,
Okay, so one question I saw was any recommendations when to mock. I had situations where people were mocking everything, but the test was worthless, and this is a good point. So there's a very like quickly snapped off response where it says don't mock things that you don't own, meaning that you should be creating doubles of things that you cannot control yourself, meaning some third party is responsible for it. But I think that's not a super helpful way to look at it. I think sadly the actual answer is that it depends, right? Which is not an answer people like. Like you don't necessarily have to use the mocking tools that are available via your test framework of choice. I have definitely written tests where I have created fake versions of various components that the code is working that simulate what the dependency does. Because you can create fakes yourself. You don't necessarily have to use the tools. A lot of times you are just using PHP's internal reflection API to duplicate some object and then extend it to do what you want. So sadly, testing is still sort of a handcrafted artisanal process. And all I can do is offer some generalized advice and for specific situations. Look at every dependency, that the code you're trying to test has and figure out, could I create my own version of this dependency? Or do I need to create a pretend version of it that behaves in a very specific way? And someone said they never expect to say that I'm happy. You all need to understand the grumpy programmer thing is marketing. I am actually a very happy person, and I do enjoy my life and stuff. And if I was actually the way I used to be on Twitter all the time, I would have been unemployed for a very severely long period of time. So the next question I saw was, how do I decide how small the unit is that I test? Okay, so here's a great way to look at this. If I'm writing a test, I would look at that method of the method of a class object. Then I would take a look and say, okay, what is this method doing, right? What values are they returning, right? You look at what are the return statements? What is it doing? If there are side effects happening in the code, meaning that method, when it gets run, triggers some other event, can I detect what that side effect is? And then armed with that stuff, then I start looking at, okay, I have a couple conditional statements, and then I have 3 possible outcomes. All right, so now I know I'm going to need at least 3 tests to cover all those potential outcomes. So again, very general advice, try to apply to specific things. But yeah, look inside your code, look at what's being returned, look for conditional statements, look for loops, look for side effects, and that should tell you the number of tests that you need to write. And then based on what you need to test, that will tell you how much work am I going to be doing, how much setup work is involved, how many assertions am I going to be doing. There's no need to apply a rule such as 1 assertion per test. It literally doesn't matter. We're trying to verify that the code behaves as expected. Someone also asked, should you expose to test private methods? I believe that private methods are an obstacle to writing tests. They force you to perhaps write getters and setters when you don't really need to do that. Stop relying on protected and private. Make everything public. It will make your tests a lot easier to do. Yes, and a further up thing, you should be testing. You should be testing public methods. If you find yourself in a test scenario trying to figure out how can I access and modify a private method, you need to go back and refactor the code so that messing with that private method or calling that private method is no longer required. So with that, I need to go cough up a storm due to my allergies. So I want to thank everyone for coming out to my talk. Lots of great questions. I will be sticking around in the channel after I go get a drink and sorry, it's already starting, and get my coughing fit over with, and I'll be glad to answer some more questions in channel here.
Okay, thank you very much, Chris, for being here with us, for your talk and all of the answers to the questions.